team lead of a decentralized reliability engineering team at DFINITY, and in this video I would like to explain you what the ICOS version election proposals are and how you can verify them. As a target audience for this video, I would imagine a technically apt developer, but one who has never thought about how new ICOS and replica versions are released and now wants to learn this. I will show you how to browse the IC repository, how to do a quick check of the changes presented in the proposal, how to run the verification script from the proposal summary, and explain you how and why the verification steps from the proposal summary are a decent protection against malicious activities, since they make it much harder to sneak in malicious code into the deployment. And also I will briefly cover the IC version deployment proposals, which are a different kind of proposals. So what does the ICOS version election means? With the version election, the IC community member checks that the code changes in the new version are aligned with expectations of the community member, and the community member agrees to upgrade the IC to this new version. In other words, the IC community member pre-approves the rollout of the new version. As a part of the verification process, the IC community member also independently checks that the new guestOS upgrade binary, which includes the IC replica binary, can be built reproducibly from the provided Git revision, and that the new guestOS upgrade binary has the exact same cryptographic hash as the one in the end proposal. Why is this important? This means that we are 100% certain that the IC nodes will run this particular code that was committed in this particular Git revision, and not some arbitrary code that may have some malicious parts. This provides us a very strong guarantee that the IC running on a particular version is actually running the code that we claim or that we believe that it is. All right, so let's get going by first checking out the release notes of one particular commit. The commit is here DE29A1A, and the summary of this Git commit are provided with changes, provide changes since Git revision 8.3.1. And if we click on this previous Git revision, you can see that it also has changes and changelog. You can also review that, but that was already reviewed and deployed earlier. And it also has a list of subnets later on that it was deployed to. So now if you go to this new Git version, you can see the release notes since the previous one, and there is a list of changes, list of commits made, grouped by the feature, bug fix, performance improvement, etc. And then there are Git revisions in each line, and this Git revision takes you to, if you click on it, takes you to a particular commit in Git, and you can review what the description of this particular Git commit is, and whether this description matches what the changes are. There are a number of changes in a particular proposal, and reviewing through all of them may take a decent amount of time, let's say an hour or two, maybe even 3 weekly. We have one release weekly, and going through all these commits may require knowledge or understanding of a large part of the IC repository or the code base. And yeah, you need some time to understand what the changes are. But even before that, you may provide value to the verification process. And how is that? You can take a look at the commit messages here, and if you notice that something is suspicious or not really in line with your expectations or understandings, let's say you open git commit here, you can add some messages here, you can add comments, notify some people that you're making some comments here, you mention them, and yes, you can interact with developers and ask questions. Then if you agree that all these changes should be deployed in a new version, you still have one more step to do, which is to verify that the build is indeed reproducible. To verify the reproducibility of this Git version, we provided some steps here. You can open this link here, and it will provide you steps and explanation how to verify. It basically provides you similar information as what we provide in a particular NNS proposal. So you should verify this particular proposal by running this particular command provided in the summary, in the proposal summary, running it in Ubuntu 22.04 or newer, with say 16 or more gigabytes of memory and at least 100 gigabyte disk. This can be either a laptop that you have, or VM on some cloud provider, or a server that you have home, anything you like to. Right, so let's move on and then open a terminal here. So in this terminal, I will copy paste the command from the NNS proposal, and in the command itself there is a mentioning of a particular git commit, git revision that we are proposing. And what the command does, let's run it here, and while it starts running, I will explain some additional details. So the script, what it does is checks whether you have an appropriate operating system, whether you have enough memory, whether you have enough disk, and so on, some prerequisites. And then it starts downloading the guest OS, the host OS, the setup OS, everything that it needs to verify reproducibility. And after that, it builds the new image locally and compares that. We're going to see that in a second. Move back to the browser. All right, so let's open Git repository here. All right, so here's a script that we just started running in the background. In the beginning, there is a lot of technical details, setup prerequisites, checking out the repo, etc., etc. And then later on, the script will download from the CDN, from the internet. It will download the images that the IC nodes would download in the upgrade process. It will download the guest OS, the host OS, and the setup OS, all three of them, and it will check the CI hash for all three of them as well. And then it will build same image locally. Here it goes, git fetch, git checkout, and then it runs this command build IC --ICOS. And after this command finishes, the build will have completed locally as well. And then it takes the locally built images and computes the hash of them and compares the hash that was built locally, of the image that was built locally, with the hashes that were built by the CI. And if all of them match, it will print the command, all images are validated successfully. It will take anywhere between 15 minutes, if you have a fast computer, to, let's say, half an hour or an hour to verify the entire build. What we build in this verification script is both guest.os, host.os, and setup.os, although in this particular proposal we only care about the guest.os. All right, so this also all explains what the proposal summary is. In addition to the proposal summary, which is generally just for humans to review, there is also payload. And the payload is parsed typically by machines. Machines do not, or IC nodes do not care about the proposal summary, they just care about the payload. So that's also a very important part of a proposal. In the payload of this proposal, there are several download URLs. These are different URLs at which the update image is available. And the verification script will download all of them and compare them with compare the hash or the SHA-256 hash of these download images with the one built locally with the one that is in the proposal. The proposal payload also includes some replica versions to unelect. What this means is we do want to have a very short list of versions that are valid to upgrade or downgrade to any point in time. And that's why from time to time our automation submits also a list of versions to unelect, so that the versions that are elected at all times are very short as possible, but still provide us enough flexibility to upgrade or downgrade to the version that we want. All right, in the proposal summary, there is a link to the forum post as well, typically, and you are very welcome to open that link and to comment or reply to that post and make any comments that you would like to. All right, so let's go back to the terminal now and check whether it's finished. Yeah, it's still running here. While it's running, let me try to answer a few more questions. As you have seen, the proposal verification script downloads the source code of a given Git revision and builds the ICOS disk images and the binaries and compares the cryptographic hashes of these images and binaries with the ones in the proposal, or at least provides you with the ability to compare them. How does this provide any verifiability? Or in other words, a savvy community member could ask, there are multiple URLs in the NNS proposal that all belong to DFINITY, and the verification script in the proposal, it also belongs to DFINITY. How can I be sure that the DFINITY cannot just change the contents of these binaries or of disk images after submitting the proposal? As an answer, even within DFINITY, we don't trust any single person or any single company, outside company or entity. And that's why we invested a lot of time and effort into reproducible ICOS builds and we also have multiple URLs with the upgrade images. This allows us to continue normal operation even if one of the available URLs does not have the correct checksum anymore, cryptographic checksum. So all these URLs are expected to have identical images. If any of them do not have the expected checksum, the node will just skip them over and continue with the other image. And it will check and confirm the SHA-256 hash of each downloaded image and confirm that it is the same, identical, the same as the one that was approved by the community. This hash is included into the version election proposal, and this allows us to make sure that there is no room for error or for malicious behavior. All right, so this process is now making some progress. It now it downloaded the guest OS, the host OS, setup OS, and now started to clone the IC repository and will start the build process for the IC themselves. All right, after some time, the build process completed. You can see here, it shows the guest OS images, and then the host OS images and their hashes, and setup OS images and hashes. It compares the hashes of the local ones with the ones that were built by the CI system and uploaded to the CDN. And at the end of the process, as expected, it shows that all images are validated successfully. All right, and let's go back briefly to the proposal. So in the proposal itself, there is, as we have seen, there is a summary, and then there is a payload, and at the end, there is a list of voters and votes. If you go to the list of proposals, you can see that there is a number of other proposals, and among others, there is a list of ICOS version deployment proposals. These proposals are upgrading a particular subnet. The subnet ID is provided here. So update subnet this to replica version here. And the payload of this subnet upgrade proposal is provided down here. It says replica version this string should be applied to the subnet ID that. And if you click on a particular replica version, it will take you to the description of that replica version that has been deployed and a list of subnets to which this version has been deployed so far. All right, so in summary, these ICOS version deployment proposals are configuring subnets, which are, one could say, parts of the IC to run on this new version. Since these proposals have been pre-approved by the community, we can roll out to the new version very quickly if needed, and roll back quickly if needed, since the old version is also pre-approved. These quick rollouts may be very important if we notice any problems with new version, because we avoid the necessity to wait 3 or 4 days for the community to vote on a particular proposal. But in general case, we tend to approach rollouts very carefully. During the upgrade process, each replica will fetch the upgrade image URL provided here, like from replica version ID. One would go to the bottom and see the payload of this proposal. Sorry, it's in the proposal ID here. One would see the payload, so the replica version would download the image from the release package URLs, and then it would replica process would fetch these images and compare the hashes with the proposal hashes, and then if they match, it would start the upgrade process too. All right, so that's all from my side. Thank you very much, and good luck verifying. Thank you.